In this video, we explore how we check if two variables are associated. What we actually do depends on the kind of variables we have. Let's start with two categorical variables. These can be binary variables where there are only two categories, like when we have a dataset measuring gender as either male or female. We can also have many categories in a variable, like the region of residence. Sometimes the categories come in an order, like good, neither, bad, but for us they're still categorical. What we do is we create a cross table. So we count the number of women in the category good, the number of men in the category good, etc. To properly see if one of the cells has a larger number than expected, we often have to standardize the numbers. The easiest way to do this is to express the share in a cell as a proportion of one of the categories. We basically simulate the number as if there were 100 cases in total. Now everything is on the same scale and we can compare. To make cross tables more accessible, we can use bar charts. Again, we want to use percentages so that the bars are on the same scale and can be compared. That's what percent does. Once we have comparable scales, we can look out for values that are noticeably larger or smaller. That's a tendency or an association. Like women are more likely to be in the category good, the percentage in that category is higher than that of men. It's not that all the women were in the category good or none of the men were. It's just that they are more likely to be in that category. If we have one categorical and one continuous variable, we calculate the mean or median per group. It doesn't matter which variable we think causes which. If, say, the mean is higher, this means that the typical case in this category has a higher value. So if we have a higher mean age for women, this doesn't mean that all the women in the population are older. It's a tendency. We can calculate the median for each category, or in R we can use aggregate to do this. To better understand the association, it's a good idea to look at the distribution of the continuous variable for each group. We can use a boxplot or better a histogram or kernel densities for each category. When both variables are continuous, we can use a correlation. Here a scatter plot will be useful. When two continuous variables are correlated, those with a higher value on one of the variables tend to have a higher value on the other, or a lower one in the case of a negative correlation. Again, it's a tendency, and in the scattered plot we can see that there are indeed some people who are old and poor, but they're not the typical cases.